Hello there! Welcome to today's video on different aspects of a quadratic function. So here I have the quadratic function f of x is equal to 3x squared minus 12x minus 15. And I know that's a quadratic function and its graph will be a parabola because the highest power on x is 2 and all of the other exponents are non-negative integers. So now when I think about this quadratic function, the first thing I want to look at to determine whether the function opens up or down is to look at the sign of the coefficient in front of the squared term. So since this coefficient in front of the squared term is 3 and 3 is positive, that means that our quadratic function, our parabola, opens up. So we have, since a is equal to 3, which is greater than 0, it's positive lead coefficient, our parabola opens up. Now when I think about what that looks like, a parabola opening up, I can visualize that this function, as you follow the curve from left to right, has this bottoming out place before it turns around and goes up again. So that helps us answer the next question. Does a function attain a minimum, smallest, or a maximum, biggest, value? And we see that as you follow the parabola, it bottoms out. So we have that this function attains a minimum. Now, what about its value? Well, we will answer that actually after we look at part C. So part C, we have to do a little bit more calculation, and for part C we want to find the vertex. So remember, if we have a function f of x is equal to ax squared plus bx plus c, the vertex is the ordered pair h comma k, where h we can find by the opposite of b over 2a, and k we can find by running that number through the function. So here our h, well, a is 3, b is negative 12, and c is negative 15. And we're getting that from our function above. So let's actually write those values closer to the work. So in our problem here we have a is equal to 3, b is equal to negative 12, and c is equal to negative 15. So our h coordinate of our vertex is the opposite of negative 12 over 2 times 3, so that's positive 12 divided by 6, or 2. And then our k coordinate of our vertex is running 2 through the function, so that'll be 3 times 2 squared minus 12 times 2, and then minus 15. So that gives me a k value of negative 27. So my vertex is 2, negative 27. So when I look at what that means in terms of our answer to part C, we've got our 2, negative 27, and then backing up to the answer to part B, at this vertex point, 2 is the input, negative 27 is the function output value. So our minimum value is that negative 27. It's the output at the vertex. Now what about the intercepts of the function? For the intercepts of the function, remember to find the y-intercept of anything. We replace 0 in for x. So we just actually find f of 0, which is 3 times 0 squared minus 12 times 0 minus 15, or that comes out to be negative 15. and that gives our y-intercept of 0, negative 15. Now it always works out that your y-intercept for your quadratic functions will be 0, the constant term. So this term that doesn't have the x factor with it. But if you forget that, just go ahead and run 0 through for the x's and you get the same value. Now how about the x-intercepts? And our parabola might have two x-intercepts, it might have one x-intercept, or it might not have any. You're always guaranteed a y-intercept, but with the x-intercepts it just depends on the way it opens and where the vertex is with relationship to the x-axis. So to find the x-intercepts, we put 0 in for y. So that gives me 3x squared minus 12x minus 15 is equal to 0. Now that gives me that quadratic equation to solve, and in an earlier tutorial we found that you could solve a quadratic equation by either factoring if the expression is factorable over the integers, or the quadratic formula, or completing the square. Well, I see in this one that every single coefficient is divisible by 3. So I could actually, and it's an equation, I could actually divide both sides by 3 to make this a little bit easier to work with. So this gives me x squared minus 4x minus 5 is equal to, and 0 divided by 3 is still 0. And then I can see that is factorable. That's x plus 1 times x minus 5 is equal to 0. And then setting each factor equal to 0 and solving, I get x is equal to negative 1 or x is equal to 5. And so that gives me two x-intercepts. Negative 1 as an x-coordinate will give me 0 out for a y-coordinate, and 5 in for an x-coordinate will give me 0 out for the y-coordinate. So my intercepts of my function, I have a y-intercept of 0, negative 15, and then x-intercepts that are negative 1, 0, and 5, 0. Okay, next up, axis of symmetry. The axis of symmetry is the line of symmetry through the parabola. So back up to our little sketch here. It'll be that vertical line that goes through the vertex. And when I think of the equation of a vertical line, it's x equal a constant. And here it has to be x equal the x-coordinate of my vertex. So x equal 2 is my axis of symmetry. And then lastly, the range of the function. Well, for range, remember we want to scan our picture from bottom to top. And think about this parabola that's opening up. If I scan from below the parabola, working my way up the screen, the first y output I'll hit will be the y output at my negative 27, comma, and then it continues to go up from there. So, comma, infinity. And that is how you answer each of the different types of questions about specific aspects of a quadratic function.